Let's start chapter 5. And chapter 5, we're going to talk about probability and calculating different probabilities. So this first section, the title of it is What is Randomness? In this first section, we're going to do some different definitions and kind of get our feet wet with some of the terminology that we're going to use during this chapter. So when we talk about randomness, you can think of random as something that has no predictable pattern. Okay, so if something is truly random, there's no way to predict what's going to happen. Randomness is not always easy to achieve. We always want to use technology. So like when we're pulling a sample and we want to pull it in a random way, we'll always use technology to help us. And so for us, that'll be StatCrunch. Probability is used to measure how often random events occur. And I know you've heard the term probability, of course. What is the probability that something's going to happen? What is the probability that it's going to rain today? What is the probability that if I flip a coin, it lands on heads? Theoretically, those things are random. And so the probability is the likelihood of how often those things are going to occur. There's two main types of probabilities that we're going to talk about. And in this section, the first one is called theoretical. Theoretical probability, and then the second one is called empirical probability. And you'll want to be able to make the distinction between these two types. All right, so what does that mean? So theoretical probabilities you can think of as the long run relative frequencies. Okay, so what does that mean? If I were to flip a coin 1,000,000 times, 1,000,000,000 times, as many times as I could think of, an infinite number of times. How often is that coin going to land on heads? How frequent is it that it's going to land on heads? That's what we mean by the long run probability. The relative frequency at which an event occurs after, really it's infinite. So infinitely, I'm going to call that infinitely, many repetitions. Many repetitions. I think I spelled that wrong, but repetitions. Anyway. So theoretical probabilities are what should occur after an infinite number of repetitions. On the other hand, we can also have empirical probabilities. So empirical probabilities we can think of as relative frequencies that are based on experiments or observations. Sorry for the small spacing here, observations of some sort of real life process. So if we run an experiment and we notice that a coin lands on heads 2 out of 10 flips, for example, that would be the empirical probability because it's based on what we observed in that experiment. So let's look at some examples here and let's see if we can classify these as either theoretical or empirical. So the first one says, your friend claims the probability of getting a 6 when rolling a 6-sided die is 1 out of 6 because the die is equally likely to land on any of 6 sides. So this would be a theoretical probability. We expect if we were to toss it 6 times, exactly one of those times it would land on a 6 because there's 6 sides, 6 possible numbers for it to land on. Does that mean that it's going to happen that way every single time? No, I could toss the die 6 times and 3 of the times it lands on 6. But theoretically, if we were to do this an infinite number of times, for every 6 tosses, one of them it should land on a 6. So that's our theoretical probability. The next one says, a classmate is trying to figure out the probability of getting 3 heads when flipping 3 coins. He flipped 3 coins a total of 10 times. And in one of those 10 times, all 3 coins landed heads up. So on the basis of this outcome, he claims that the probability of 3 heads on one flip is 1/10. So is this theoretical or empirical? Well, he's making this observation, or he's calculating this probability based on an experiment that he conducted, something he physically observed. So this would be an empirical probability. A magician claims that he has a fair coin, quote, fair because both sides are equally likely to land face up when the coin is flipped. He tells you that if you flip the coin twice, the probability of getting tails on both tosses is 1/4. So does he actually conduct an experiment? Does he actually flip the coin and count the number of times it lands on tails? He does not, so he's doing what should happen. He's saying what should happen theoretically in the long run. So this would be theoretical probability. So a couple of notes here. Theoretical probabilities, so let's fill this in. Theoretical probabilities are, and it has exactly, I'm going to take this word out, theoretical probabilities are constant. So the probability of landing on a head when I flip a coin is 1 out of 2. That's theoretical. It's going to be the same every time. When I talk about a theoretical probability, it's always constant. It's the same number. It's never going to change. However, empirical probabilities can change with every experiment. Like I said, empirical probabilities are based on some kind of an observation, and so they can change depending on what situation you're working with. Okay, why are there 2 probability models? Well, theoretical probabilities may be difficult to compute. It may actually be difficult to figure out the probability of some event happening. So theoretical probabilities might be difficult to figure out. However, empirical probabilities can always be used to help us estimate theoretical probabilities. So sometimes it's difficult to calculate that theoretical probability. So instead we run an experiment and try to get an estimate for the theoretical that way. We cannot always trust the theoretical probability model. The model may be based on faulty assumptions. Empirical probabilities can help us verify. So we might run an empirical probability to verify or refute a theoretical value. How do we run empirical probabilities? Very often, like I said, we'll run an experiment, and instead of sitting there flipping a coin 1,000 times or 10 times or 20 times or whatever, we might instead run a simulation. So simulations are experiments that are used to produce empirical probabilities. And we'll see from time to time in StatCrunch that we can use StatCrunch to help us run these simulations. And so a lot of times we'll use that to calculate the empirical probability of something.